This video mainly introduces the engraving parameters in our settings. First, let's take a look at the marking options. The two rows of conveyor belts above go from right to left. The conveyor belt ascends from left to right to trigger automatic sorting. The characters are engraved facing forward. These are common options, so let's move on. To introduce the trigger delay enable. Trigger delay enable means that after receiving the trigger signal, it can be delayed for a certain distance or a certain period of time before performing the engraving action. That's the trigger delay enable. Next is the minimum interval trigger enable. The purpose of this function is to prevent accidental triggering. You can set a specific distance or time within which the second trigger is considered invalid. Only triggers exceeding this set value are considered valid. Only triggers exceeding this set value are considered valid. Only then will the engraving action be executed. Next is the use specified coordinates feature. This feature is very important. It can greatly improve the situation where the conveyor belt speed is too fast. Generally speaking, if my conveyor belt goes from left to right and my field length range is 110, then I will set the coordinate value to -45, which means half of the field length range, 55 in this case. So I set this coordinate value to -45. This way, the starting position of the graphic circle will be moved to this position for engraving and marking. Next is the buffer count. The buffer count refers to how many data we send to the card as a buffer. Usually, setting it to 1 or 2 is fine, but never set it to 0. Finally, there is the minimum feeding distance. This parameter currently makes no sense. Let's move on. Look at the input ports. The input ports are different triggering methods, such as NP and single end triggering, plug-in input triggering, and distance triggering. There is also internal triggering in our software. Usually, internal triggering is used for debugging purposes. Finally, is the conveyor belt. There is the encoder for the conveyor belt. There are two calculation methods for the encoder. One is based on the diameter of the encoder, and the other is based on the pulses of the encoder. To calculate the pulse distance, let me introduce the encoder first. How it is calculated. Mark two positions on the conveyor belt before it starts moving. Then, turn on the motion, and it starts moving. Pay attention to the pulse count. It should increase in the positive direction. Also, the speed reference should always be positive. Then, after the conveyor belt has traveled a certain distance, we turn off the motion of it and take a ruler. To measure the length of this distance, click on End Motion and enter the measured value. Assume the measured distance was 1 meter. If the unit here is in millimeters, we need to convert 1 meter to millimeters. After entering the converted value, we click on Calculate. It will calculate the pulse distance for your conveyor belt. Next is fixing the conveyor belt. There is nothing special to mention about it. Static marking means using a non-conveyor belt method. Static marking, usually, it is used for debugging purposes. That's all.